So, students, today we will discuss the spectroscopy and its applications. So, what is actually a spectroscopy? It is the study of the interaction between matter and electromagnetic radiations. Actually, we are following electromagnetic radiation on chemical, whether it is a salt or any other, you can say liquid substances. So a special kind of patterns and peaks will be observed on the screen, and we can analyze it. So for example, as we have seen that it's very difficult for a chemist to identify the nature of the chemical, nature of the salt, its properties and its structure. And because in chemistry there are salts which are having a similar kind of character, so they are looks like exactly similar. Because if you will see having a white color salt, you will find number of salts having a white color. So it's very difficult to identify its name, its character and structure, etc. So the only technique is the spectroscopy technique, by which we can identify its complete geometry, structure and nature of a particular chemical by following the electromagnetic radiations over it. So what kind of spectroscopy? Yes, we are having lots of spectroscopy like ultraviolet, visible and infrared, NMR, ESR, Raman spectra. So lots of spectroscopies are there. Mass spectroscopy is there, but in your syllabus there are three kinds of spectroscopies, that is UV, IR and nuclear magnetic resonance spectroscopies. Now the next is electromagnetic spectrum. You will see different kind of radiations are there, showing different wavelengths and frequencies written over there. Visible spectrum is also there. So it is actually an arrangement of all types of radiations in order of their increasing wavelength, or you can say decreasing frequency. That is called electromagnetic spectrum. You will see gamma rays, X-rays, UV, IR and other radiations are there. A common spectra is there, that is called electromagnetic spectra. You will find this spectra in each and every you can say spectroscopy technique. Yes, the next is absorption and emission spectra. This is important one. Absorption means when we are absorbing something. So it is in case of atoms, molecules. You will see in the picture an atom is absorbing energy in the form of HV is there. So it will absorb energy, light energy, and it will move to the excited state E2. So atoms and molecules are moving from the ground state to excited state by absorbing energy. So the spectroscopy is called absorbing spectroscopy. But in the excited state, it will feel instability and it will release the energy and it get back to the ground state. So because emission is there, so the spectroscopy is called emission spectroscopy, and the spectra obtained is called emission spectra. Yes. So these are some molecular spectra we will discuss in the class, like rotational spectra, vibrational spectra. These two spectra, the rotational and vibrations, it will be discussed in the infrared spectroscopy. You can say IR spectroscopy, and electronic spectra is totally based on the, you can say, ultraviolet and visible. But in NMR spectroscopy, it is a nuclear magnetic resonance, you can say study of the protons. Raman spectra, ESR spectra, these are also spectra, but they both are not in your syllabus. We will discuss these four: rotational, vibrational, electronic and nuclear magnetic resonance. Next is a spectrophotometer. It's a simple diagram of a spectrophotometer. It's a machine type, or you can say it's apparatus by which we can get the information of the chemicals or samples, you can say. So it's having a light source in the one side. After passing the light from the light source to the collimator, it will be directly moved to the prism. After passing through the prism, it will be directly falls on the, you can say, slit. In the slit, the light will have the only one direction. You will see the yellow light is totally falls on your sample solution, and after passing the sample, the detection will be there, and there is a photocell. It will be detected by the photocell, and after that you will find the data of your sample solution. It's a normal simple you can say picture or a diagram of spectrophotometer. So next is UV and visible spectroscopy. UV and visible spectroscopy deals with the transition between the electronic energy levels of a molecule. Actually, electrons are moving from one state to another state, so that is why it is called electronic spectroscopy. So you can say the second name of UV and visible is called electronic spectroscopy, because totally movement of electrons are there. And after that, electronic spectroscopy, you can say having a different kind of frequencies. Ultraviolet radiation having different frequencies, and visible radiation have different frequencies. The molecules who are visible in 200 to 400 nanometer, that is in UV spectroscopy, and if it visible in 400 to 800 nanometer, it is called you can say visible spectra. So in the next class we will discuss the type of radiation, how the electrons are moving from one state to another state.